Hey everyone, welcome back to my channel. Today we are diving into the fascinating world of exploring R in bioinformatics. Now you might be wondering, why should I care about explore R in bioinformatics? Well, my friend, let me tell you, this is one of the most crucial aspects of modern research and data analysis in the biological science. So buckle up and get ready to have your mind blown. If you haven't already subscribed my channel, I encourage you to do so for the most up-to-date videos and the solution related to the bioinformatics.
In the preceding video, we covered the models and formula in R. Now, in this video, we delve into discussing charts and graph in R. So, we have already uploaded iris data set in the previous video. This is our flower data sets. So, we have to name iris, enter. Okay. Names. Yeah. So we already have sepal length in that, sepal width, petal length, petal width, species. So I'm gonna create a histogram, JST dataset dollar sign sepal length. Okay, so I hope everyone is familiar with the histogram, and you can see in the right hand side the histogram what actually do is to underline the frequency distribution of a variable. The variable will be the continuous. In the x-axis of the histogram represent the range of the values of the variable, okay, which is divided by into the intervals or bins. So while in the y-axis you can see the represent of the frequency or a count of observations falling into each bin or intervals. So this histogram shows sepal length having been set 4, 5, 6, 7, 8, and we get this a nice bell-shaped curve where few have been having a long sepal length in the middle, and you can also create a histogram with the petal length also, petal length, petal width, whatever you want to see. See, in this graph we can see the more number of beans at 1 and 2, and it doesn't show the bell curve, but after 2.5 it will shows a bell curve. So that means we have to do some EDA exploratory data analysis and remove the noisy data. Let's move further. So now we can go with the hist iris iris 7th comma, uh, we can see the syntax hist, and you can see there is a breaks. Okay, so now we can modify our code and we use the breaks. So we have to breaks into 25 minutes. So you can specify the number of breaks or bins to divide the data range into. A higher number of bins provide more detailed view of distribution, but too many bins may result in noise or make it harder to discern pattern. Okay, so it will break into the so many segments as compared to previous one. We do this because it gives us more idea of how the distribution breakdowns, and when we earlier saw it as very well bell shaped curve was there, but when we add breaks, a bell shape having noise in it, you can clearly see that. So you can look into our data in many different ways, in which one is to change the bins. Now we proceed further. First I have to comment it out. Of bins. Now we can copy this. Oops. Add some add labels. Now we can add some labels. So we can back to this syntax, our documentation, and we can see there are a lot of things over there: frequency, probability, include lowest, right, true. So we are using xlab. X xlab is equal to sepal length, and we are using main. You can see paste histogram off, so we can main sepal frequency of sepal length. So this is the histogram. You can see sepal length, frequency of sepal length. Okay, so this is histogram, a kind of a bar plot. Now we can plot to another kind of graphs. Dot plot, plot iris dollar sepal length iris sepal width, comma, again I am using xlab. Make sure it will be in the quotations because it's a character, and here I am using ylab. ctrl plus enter. Oops, I forgot to put in the quotes. Now you can see a kind of a correlation between sepal length and sepal width. We can subset this by calling a lattice library. Lattice. Let's look into this library, lattice, and this is a add-on package. And now we can see there are different functions over there: univariate, bivariate, hypervariate analysis. You can see the examples also. Now we are going to create a dot plot. Dot plot dot paddle dot width. Oh, start with sepal. First we check with sepal width and sepal dot length length piper species data iris. Now you can see the right side. Here is the result. What actually happen is there we can create a dot plot with lattice library, and here we sepal width versus sepal length, and where a subset is species. So there are 3 species in there. Here you can see the result, and if you go and check the previous result you can clearly see this. And here in the species virginica, setosa and versicolor, you can if you draw a line, a best fit line between them, so that's relation is very strong. Here if you can see this kind of data appear in this here, a vesicular data. You can check this and this, and this is the overlapping between the virginica and setosa. So if you overlap the data, so this kind of dots you can see. Now we can also check with the petal length and width. When we click, you can see the result. We can also the pretty sure correlation between them, between the petal length and petal width, but not in setosa as compared to versicolor. Here it's a very strong correlation between them. Virginica, it's totally so much of noisy data over there. So that's it for the basics of R. Now we move some bioinformatics projects and use some libraries like dplyr, tdverse, net, and now I'm going to create another playlist with the R markdown. So stay tuned, and if you didn't subscribe my channel, go and subscribe my channel, because now we are moved to the bioinformatics part. Thank you, and see you in my next playlist.